Good morning, everyone. Welcome to our first installment of the STEM at Work seminar. My name is Manisha. I will be your host today. As many of you know, we're participating in our 2021 first Game Changers season. And for many, the Innovation Challenge presented by Qualcomm has been a way to take on society's greatest challenges and create long-lasting impact in our world. Before we kick things off and meet our panelists for today, I just want to say a huge thank you to our sponsors. That's Raytheon Technologies, BAE Systems, National Grid, Boston Scientific, BNY Mellon, Analog Devices, PTC, and the Fay Trust. Is everyone ready? Is everyone ready to go? Our first panelist comes from the mighty state of Maine. McKenzie is an alumna of FRC Team 2648, and she attended WPI to study biomedical engineering. After college, she joined PTC as an application engineer and now works on the education team. She also volunteers with FIRST as a referee, scorekeeper, first technical advisor assistant at New England First events. So you've probably seen her around. She's also co-led a session on the Chairman's Award submissions during the 2020 New England University Day. Our next panelist comes from Mathworks. His name is Akshay. He's worked at Toyota, General Robotics, Automation, Sensing Perception Lab at Penn, Bose Research, where he first got his first patent as an inventor, and perhaps his most favorite job at Cummins. Now, he currently is co-founded the Advanced Research and Technology Office at Mathworks, where he works on research and technology development initiatives between Mathworks, university researchers, and industry practitioners. He also has his master's and his PhD, so if anyone's interested in academia, he's your guy. Our next panelist comes from New York. Dean was first introduced to engineering through First Robotics Competition Team 4122. He then attended WPI for his undergraduate degree in robotics engineering. Recently, he's worked on an unmanned underwater vehicle at a startup Riptide before the acquisition at BAE Systems. He's now working at BAE as a UUVS, as a member of the Engineering Leadership Development Program, as a BAE and FIRST coordinator. Our final panelist comes to us from iRobot. Erik is a senior test engineer focused on building robots to test robots. He has a diverse engineering background with experience working in commercial, medical, aerospace, and defense companies. Having these different roles has been amazing because he's been able to see product design engineering, managing small teams of engineers, and he's utilizing his master's in computer science and bachelor's electrical engineering to, innovate and do wonderful things. So now that we've met our panelists, I'd like to open it up a little bit. We're gonna popcorn around to each of our panelists and see how have skills in the Innovation Challenge that FIRST teams are applying right now, how do they play into the real world? So working as a team, trying to come up with innovative solutions. Does anybody have any particularly notable stories they want to share before we get into things?
I can go ahead and share a story. So when speaking about innovation, I think one of the things that can be really hard is it feels like there's already so much innovation out there and there are so many products that are already developed, and it may feel like technology has come so far. So what can I do that hasn't already been done? And so I work at PTC, and we have been in the CAD software industry for a very long time. And I'd say one of the really important things is to see that technology can still be developing and can still be innovative, and you can always be looking at ways to continually improve on the things that are already out there around you. So when looking for ideas for this innovation challenge, it may have been hard to try and think about what can I do that hasn't been done yet. And so making sure that you can see, even if something's come a long way, how can you take it another step further?
Awesome. That's, when I thought about the Innovation Challenge, I was like, what do I have to bring to the table? What could I possibly contribute when there's already so much wonderful innovation going on? So hearing your story has been really powerful for me. Is there anyone else who would like to add anything?
Yeah, I think building on Mackenzie's point there quick, right? So being part of a startup, right, there's, we built these underwater vehicles, and there were, plenty of other, multi-million dollar companies that have been acquired by these, massive, General Dynamics, all these big defense contractors. And our CEO at the time started it in his kitchen with a 3D printer and, made the first prototype. And 3 years after that, first kitchen experiment, they were acquired by BAE Systems. So it's not necessarily being the first one to do it and, the best one to do it even, but it's, being, a disruptor in the market is really key, especially as, like McKenzie's talking about, lots of things have been done to some extent already.
And I think you don't have to be the first in the market. iRobot was, but even when you're the first, what happens is you got to keep moving because you've created this market. You've created something that didn't exist before. People are going to take notice and they're going to want to come in and they're going to want to share in the goodness that you've created. So you keep moving, you keep defining your product in the space within the market that you've created.
Yeah, and just to add to that, I think doing your everyday things like you always do, keep an eye out on where there can be pain points, where can things be improved. If you are struggling with those, it's most likely that other people are too. So there's your chance to innovate, even if things have been working well. There's always a chance to improve them.
Really love that advice you just gave. I think a lot of, I know I definitely, when I was younger, I would have loved to hear that. It would have been super encouraging as like, you're going out in the world, you all have different perspectives to bring. So hearing that, diversity of thought is one of the wonderful things about innovation. We like that. We like to hear that in any first. So I'm just going to open it up a little bit. Now that we've addressed some of the innovation challenge specific, core values, what advice would all of you give in selecting a college and major? All of you come from diverse backgrounds of first experience, non-first experience, different engineering disciplines too. What drove you to choose your specific path?
For me, it was actually a fit. So for my undergrad, I went to RPI, Rensselaer Polytechnic Institute. And I went to a couple of different schools, WPI, Purdue, and I think I went to BU also. And for me, when I got on the campus, it was just a sort of, this felt like the size of school I was looking for. It felt comfortable. And it felt like a place that I could see myself being, because at the end of the day, when you do go to school, you are going to be there for approximately 4 years, depending on what your major is. And you have to be comfortable there. It has to feel like it's going to work.
Yeah, so I actually wasn't sure when I was in high school what I wanted to do. So I was kind of, looking for, my right fit, my right path. So even after going to college, so everybody in my family was either a mechanical engineer or not an engineer. So, but I didn't want to do that. So in my freshman year, I chose electrical engineering. And then after the first year, I actually switched my majors to electronics and telecommunication. So slightly different. But still, I think the real idea I had about what I wanted to do in life was my first job out of college. So I think this first is probably a great opportunity for young high school students to try out things about what they like to do in life, and use that as to their advantage when going to college. And then I think in graduate school, I think I just chose interdisciplinary things based on my first job out of college. And that has led me to a path that is a confluence of electrical engineering, computer science, and mechanical engineering, bits of pieces of all of those. So like real physical things as well as software, computers, all of those.
I think it's important to note that you also just highlighted the fact that just because what you did in undergrad or what you did in high school doesn't necessarily mean you're going to do the same thing for the rest of your life. It's going to change as your interests change, as you find out what your strengths and weaknesses are. I really like that you talked about that. McKenzie and Dean, you both come from first teams. So did your first team experience influence what you chose in college, influence your career path or any of your interests?
Yeah, so I could speak to that. So none of my family are engineers. So, to me, an engineer could have been, the guy who drives the train, right? I didn't really have any sort of notion of what it was. So my junior year was the year that the team started at my school, and I figured, why not? Right. And hindsight's 2020, right? There's nothing I really think I would have done except engineering, right? I liked math and science, but not having the exposure to the field, I just never really considered it. So it really guided me towards engineering in general. And from there, kind of similar to, what Erik was talking about, right? Just visiting the campus, it just felt right. And from there, it was, choosing a major and doing, first robotics. There was a robotics engineering major at WPI. So I decided to go down that. And I really liked it because I didn't have to pick mechanical, electrical, software. It was more of a combination of everything. So I really found a good place in that. And then, going to a little company worked great. And then at the bigger company, they really just look for a title to put your name in, right? It doesn't mean if you're an electrical engineer, you're going to be designing circuit boards or anything, or, if you're a software engineer, you're not going to be, 100% sitting behind the computer all day. So, just because your major does, you think makes you fall under something, doesn't necessarily mean that's, the rest of your life from that point on. So take it with a grain of salt.
Yeah, I had a very, very similar story where I had never heard of engineering. None of my family was engineers, but it was also first that helped expose me to engineering as well. And one of the really cool things that I had an opportunity to do is someone on the team, their parent worked at Maine General Hospitals, and they invited us to actually go and sit in the room while a robotic surgery was being performed. So they had one of the really cool Da Vinci robots where I don't know why they allowed us to do this, but I was literally sitting in the room beside a patient being operated on and got to see this happen. And it was one of those opportunities that it was just because of my team that I was invited to do that. And that made me think I want to go to biomedical engineering because I want this engineering and I want to work in the medical field. But one of the things that I didn't really realize or look into enough at first is pretty much any engineering discipline can go into any industry. And they're working on that robot. I didn't need a biomedical engineering experience. I would have probably been better off with a robotics engineering or electrical engineering or maybe even computer engineering. And so I wish that that was one of the things I had done differently, was looked more at the specific skills and less at the industry that I wanted to go into. And then I did end up going into software, and that's where I am now. And I've really enjoyed it. And I think too, I got a biomedical engineering degree, but I'm working in software, and I think that's okay. I still have that engineering mindset, and I was able to make that transition and take different classes that helped me go in that direction later on in my time in college. And it's okay to change your major and make different decisions as you go on.
Yeah, that's awesome. I think one of the cool things about being a first student, or just, taking classes or just trying to learn, just being curious, you really do get a better feel of like, just because I'm interested in this doesn't mean I need to major in it. Like, whatever you're doing, you're learning how to learn at its core essence. Like, you're going to be learning throughout the rest of your life. And if you can figure out the best way to learn for you, whether that's like studying or practicing or whatever it may be, you're going to be set no matter what you do. At least, does anyone have any input on that?
I think learning how to learn is a beautiful thing, because you're going to go to a company, you're going to bring the skill sets that you have, you're going to work with this company doing whatever they do, and at some point you're probably going to start to shine because you have that mindset, and they're going to give you a problem that maybe nobody in the company's ever done before, or maybe this is a totally unique problem that no one in the world's ever done. And at that point, you've got to learn what you can do, what you can know. You've got to find a place to start, and you got to play with it, almost be a little child with the problem and just work with it, because it doesn't matter. You just need to, you need to figure out what you can.
Awesome. I love it. So next question that we have from our audience is, what does a typical day at work look like for you? And how is this different because of the pandemic?
I can give my typical day at work is somewhat standard because of what I do, building robots to essentially break robots. It's sort of hard to do a lot of this remotely. So I typically go into work and then I have projects that range between 2 weeks to 3 to 4 months, and I will look at where I am on that project. A typical day is either debugging or getting specifications or purchasing or integration work.
What's your favorite thing about that?
Definitely the debugging. It's getting into the problem. I'm happiest when I get into the problem and you're just there and time is gone, and you'll be in the problem for a while, and you poke your head up and you're like, I'm hungry. I wonder if it's honey, yeah, I'll be home for dinner soon. Yeah, I gotta leave. I'm in trouble. But it's just when it pulls you in and your whole brain is going, and time doesn't matter anymore. It's just the problem, and you're just in there and you're working on it.
That's so funny. I'm sure all of us have had moments like that. So to hear that you get to do that as part of your job is probably really, really fun.
Yeah, so a big part of my job is the integration and test of our systems. And given they're underwater, you need to go out at sea to test them. So a lot of my job involves going out on the boat and taking these out for the day. Sometimes it's just a day trip out into Cape Cod Harbor, kind of where we're based, or it could be a longer multi-day trip out to deeper water if we need it. So I've been pretty kind of spoiled in that sense to kind of get such a cool hands-on job pretty early. But definitely one of my big recommendations is work your way into some sort of field work at the beginning. I think if it's hardware based, seeing it in action and whatever environment it's supposed to be in is always really useful. You can write software for a long time, but if you never see it in action, sometimes it gets a little bit distant. You don't necessarily have that connection to see what it's doing, and it could always definitely help improve your engineering by understanding the full use.
I'd say for me, my days aren't very typical in that. So I work on our education team. And so I have a few different roles that I do continuously. So I help with support. So if you've ever put in an on-shape ticket, I may have been one of the people that responded to your ticket on the support side. So you may have seen my name there. And then I also do a couple of different training programs where I'm training other students or teachers or doing webinars and things like that as they come along, or I'm helping put together design competitions for students or different trainings or things to put on our learning centers. There's a lot of different projects that go on, but it's no day is really the same. So that's what I like about my job, is that I don't have a routine, and it's kind of what is going on right now for projects and what can I be doing, or maybe I don't have as many projects right now. So this is a good time to work on some models that we can put out into the community. So definitely fun to have a less consistent schedule.
Yeah, so I have a similar thing to add, which is almost no 2 days are alike. I wear a lot of different hats, and sometimes I don't even know what to kind of call myself, my job profile, So sometimes I'm basically organizing research conferences on behalf of Mathworks or in the community. Sometimes I'm giving talks at the research conferences or universities. Sometimes setting up collaborations between Mathworks engineering department and researchers in the universities or research institutes. Sometimes it's basically giving advice to engineering teams about advanced use cases and where the research community is, versus where there may be gaps and opportunities to grow our product. Sometimes it's sitting on the patent review board and advising engineers to talk to lawyers and translating the language between them. And a a lot of different other things.
I think it's really cool to highlight that all four of you work in different disciplines, different companies, and it's cool to see a variability in what an engineer, quote unquote, like what that kind of means. I think it means something different for all of you, and you're all able to hone in on what science means to you, what it means for your company. How do you help, move the wheel forward when it comes to innovation or debugging, or, maybe you're in the field, maybe you're working with customers like McKenzie. Like, I think that's awesome to see that you're going to have to develop a lot of different technical skills, but I think a core thread that I'm starting to see from all of you is you have a lot of teamwork, you have a lot of communication, you have a lot of, prioritization and time management built into your different jobs. How can you speak to maybe one of the most important soft skills, if you will, that you find in your day-to-day?
Yeah, sure. I think teamwork is probably the one that maybe everybody can relate to. So in my particular job, I need to work with people from software development, from marketing, from external customers, industry practitioners, researchers, documentation people, quality assurance or quality engineers. So lots of different things, lots of different perspectives, and even lawyers and attorneys, right? So everybody has a different angle to the problem, and everybody brings different skills to the team. And one of the best things has been that I've been able to work with so many different people from different backgrounds.
I'd say one of the biggest soft skills that I've learned is definitely communication, and especially being able to communicate a technical concept to someone who's not technical. I'd say that's something that we can get really used to, our language that we speak and the words that we use that are specific to our industry or to what we're doing or the projects that we're working on. But you need to be able to share that information outwards, whether it be through sales and marketing or even just people that are leading your team, or just anyone in the company needs to kind of understand what you're doing, or to customers. So being able to take what you know and translate it and have that less technical jargon and be able to talk about what you're doing. And it's also a great skill that first students learn a lot, where you may be doing something with your team, but you need to translate it out to the school board that you're working with, or whoever else in your community you want to be sharing your information with. And some people may have questions about how your robot works, and being able to say it in a way that they can understand and relates back to that person is really a useful skill to have.
Yeah, kind of building on McKenzie's point of, having that, connection with people, right? I mean, it's more than just even in the work setting, right? I mean, it kind of bridges your whole life, but having that connection where, if you need somebody to come in on a Saturday for you because you need something ready by Monday, right? If you only know them because you've emailed back and forth a couple of times, it's going to be a lot harder to convince them to, work on their day off to come in. But as you get, closer with the team at work and everything, you'll realize that, if you're there for people, they'll be there for you. And that, counts in a lot of senses as far as, work, but also just, in meetings where, you need somebody to back you up on a point, right? Like there's that sense of camaraderie and being there for each other. That's really important, and forming those relationships early on, and, holding them close and making sure you're there for whoever you can be will really serve you well.
Erik, did you want to jump in with anything?
I don't think I can. I mean,
Okay.
We've got the teamwork, we got the collaboration, we got the communication. This is beautiful.
I feel the same way. I really love this. All right, now that we've kind of talked about what your day-to-day is, what your different roles are a bit, I actually have a few questions for each of you individually. You guys ready? All right, Dean, tell us what it's like to work on and design underwater equipment. Do you get to test it underwater too? Like, how does that work?
Yeah, so we build and design this, all in our lab, right? And there's a lot of things that you have to take into consideration. Like obviously, right, you want it to float, you want it to, be visible, right? So ours are bright orange because the ocean is a large place. You want to make sure you find it, but everything kind of ends in the lab. Once you put it in the water, you see it on the surface, it's floating there. You click your button to send it on a mission and it's gone. And that's it. You sit on the surface and, you have it pre-programmed to do its mission, but while it's underwater, no signals can get to it. So, no GPS penetrates the water, no Bluetooth, no Wi-Fi. There's no, conventional wireless signal that passes through the water. So we just wait for it. You can do certain things to try to keep track of it. You could, put it pretty shallow so you can try to see it through the surface. But you can imagine that, following it around on an hour mission isn't necessarily the most riveting thing. So lots of times we'll have it come back to where we started and we'll just sit there and wait for it. There are a couple other ways you can use to try to talk to it. If you have they call it acoustic communications. Imagine it's like how dolphins talk underwater, but for underwater vehicles. But other than that, you just kind of wait and, it's taken a while, but still every time you send it under, your heart drops a little bit because you're wondering if it's the last time you ever saw it. Because if it goes and does something you don't expect, good luck finding it. We've had a couple, go missing and then wash up a couple days later on some beach when the police give us a call because there's a torpedo with our name on it, popped up somewhere. So it's been a lot of fun, but yeah, it's every day is different. Everything we send out there is different. We've done some little vehicles that are 20 pounds to vehicles that are, 500 pounds. So you can really, make it what you want. And it's always an interesting day out on the water, that's for sure.
How often do you get to do that? Is that like you test it in the lab and then it's like your one and done? I mean, you said it's your one and done, but like, is it something that you do like once a month, once a quarter, once a year?
Typically we go out once a week testing. Before the pandemic, I would do a lot of like the customer facing training. So I would usually fly out to wherever our customers are and do their trainings there. That would happen about once a month. Obviously, given COVID, it's been a little bit less so. But yeah, we try to get out on the water once a week. It could even be more. The more testing you get on these, the more reliability you'll get going forward for sure.
Sweet. That's really cool. If any of our students have further questions that they'd like to ask Dean, feel free to drop it in chat or drop it in the question and answer feature on Zoom.
Definitely.
All right. Up next, Erik. So, did you think that iRobot would explode as fast and as big as it did? Was it always planned to be this awesome consumer brand?
No, not even close. When they started the company 30 odd years ago, it was just 3+ people. They grew it up to about 10 to 12 people, and it stayed that way for about the first 5 years. So then they started to get contracts working, and the first probably things that were paying the bills were the SUGV. So those were tracked robots with an arm. And that started to give them cash flow, which allowed them to do other things and try other things. In the meantime, they were trying to build robotic toys. They tried to do a mopping robot before they tried to do the Roomba. So the Roomba launched in 2002, and it took about 10 years before 10 million robots were sold. And then the next 10 million robots took about 5 years, and then the next 10 million robots took about 2 years. So the company's been scaling in that. And at one part, they had a defense part and they had a consumer part. And the defense part and the consumer part were sort of at odds, because in the consumer space, to do volume, you work with large contracting manufacturing houses that all happen to be in a country or a couple of countries that you don't talk to if you're in the military space. So the two aspects of the company were at odds, and at some point they decided to split the two parts of the company, and now the company is just focused on the Roomba in the consumer space.
Wow. I mean, I didn't know about that. I think that's really cool because I don't know. Did anyone else know about that? Maybe it's just me. Um, what is your favorite product that you've worked on that you can tell us about, that in terms of like the best debugging thing that you've ever had to do?
The favorite product that I can tell you about. Some of the products that I worked on in my first job. So my first job, I was in power electronics. I made a cap charger, which is a shoebox sized power supply. It takes power. It takes the power that they have and changes it into power that would drive a flash lamp for a laser. So these were dermatology lasers. The cool thing about power electronics is when it fails, it generally fails spectacularly. So sometimes when things fail, it's kind of like, I don't know what went wrong. No, not with power electronics. Usually it blows up and you know exactly what went wrong because pieces of it go flying. So that was probably the most interesting job, because when something went wrong, it blew up, so you sort of knew what went wrong, and then you got to try to figure out why, which was usually the harder part.
That's crazy. That's so cool. Akshay, my next question is for you. You have a PhD and a master's degree. Why was it important to you to achieve this level of education when you're innovating?
Yeah, I would say technically, I mean, innovation is a broad term. So I would say technically a degree is not a requirement, but I would say that master's and definitely PhD degrees give you soft skills as well as they open doors that would otherwise not open to you. So in my current role, a PhD is a requirement. I wouldn't have gotten my current job if not for a PhD. And we've been talking about things like learning to learn, right? So in case of a PhD, at least you do not get a PhD unless you solve a previously unsolved problem and you do whatever it takes to solve it. So that involves identifying a problem that is solvable, even if it hasn't been solved yet. So something not too crazy, right? So something that can be tackled. At the same time, how do you go about solving it, right? So then if you're not an expert, then you go all the way deep and teach yourself the skills and the backgrounds and the literature and everything. And then you talk to people, and then you talk to others in the industry and the community, whether it's even relevant to solve this problem. So I think those are the skills that are coming in handy, or even after so many years, and that has been really the plus, I would say, rather than the actual degree itself.
Well, I mean, you've solved some really interesting problems as a part of this. Can you talk about some of it?
Sure. I think I was absolutely lucky to find an awesome first job out of college, where I worked on diesel engine applications at Cummins, and there I basically got to go inside trains and ships and coal mines and power plants and whatnot. Every application had a different challenge. So in terms of railway, the engine will be somewhere else, but the panel would be hundreds of meters away or hundreds of feet away in some other compartment. So carrying the wires and everything down there for the defense roles, you had to be absolutely certain that nothing fails, right? For ships, it was something like it doesn't go unstable. You cannot accidentally click on it, so something had to be tightly bolted and those kinds of things. In a coal mine, it's all like temperature sensitivity. The temperature rises so high, things should not stop malfunctioning and things like that. And basically being able to cast those problems and technically and formally analyze them, that's something that I learned in graduate school. So I was able to basically tackle things that I had already seen in practice. So that was the beauty of it, about how to solve these problems in a systematic manner.
Awesome. thank you for sharing that. I'm super interested. I definitely want to talk to you more about some of those specific projects.
Sure.
My next question is for McKenzie. So you are clearly wearing a Neutron shirt, so you are a first mentor. What motivates you to stay involved and really active?
Yeah, I'd say FIRST is a great program in every way. And I'd say that being involved in it from a student perspective, you learn so much, but I think I've learned so many different skills becoming a mentor. So I actually didn't mentor when I was in college. I was like, I'm going to take a break. I'm going to just volunteer at some events here and there. And then I went back into mentoring. And I think as far as learning some project management skills with helping your team get to the point where they're accomplishing different milestones and different goals, I think that's a really important, again, soft skill that's helpful to learn. And then also just sharing that engineering knowledge and being able to talk about it and helping the team come along is really rewarding. And I think it's just helpful to have. And then also, I mean, there aren't as many girls, there aren't as many female mentors, especially. So I think too, for me, it just feels important to show some of the girls on the team that they can be technical and talk technically. And I think that's one of the things I did chairman's when I was on the team. And I think that's a really valuable part of the team and part of the experience is writing those awards and doing those things. But I more recently started mentoring in the technical side too. And I'm really glad that I did that because I kind of have realized that when I'm in the lab space, especially if there's a newer young girl on the team, they'll tend to go into the room where there are more girls. That's just the way it is. You just feel more comfortable and just more comfortable if you're in the room where there's other girls with you. It's just the fact of life. And so for me, going into the technical side and walking into the technical room, I think I want to do that a lot more, especially just to show other girls that, yes, come over here with me and do the technical side of the team too. You can do it all. You can do both. And you can see what that can sort of look like for you.
What you just said really resonated for me too. I mean, I was also on a first team. I'm also a mentor now too. And I think it's so important that as a part of this, as a part of your team, as a part of your life generally, like no matter whether it's work, school, family, friends, your community, that sense of inclusivity and bridging the gap between, whether it's guys and girls or just like any sort of group, like I also feel it in terms of like, I think you're also an example of you're a mentor now. You wish that you had more, maybe you wish you had more, but maybe you want to see more mentors like you to give a better example for not just the girls, but also the boys too. Show everybody that we all can do it. We all can grow together. I know that's something that I try to bring as well. And so I really love hearing that. It just makes me feel like everything's worth it. Everything's awesome. We have such an awesome community within FIRST. And I thank you for all the hard work that you do. Speaking of technical stuff, and bridging the gap between, as someone who also did chairman's too, how do you have an opportunity to bring your expertise with PTC to your team and vice versa?
Yeah, definitely. I'd say one of the big things that I do in my job way more than I ever realized that I would do is presenting on the work that I'm doing or leading different conversations as far as webinars or things like that. So there's so much more presenting that I ever would have expected. And so going from being a chairman's presenter to someone who is presenting on a very regular basis in my everyday life is really useful. And it's helpful to have those skills as well as the writing skills that I got from doing the chairman side of things. And they're writing documentation a lot and trying to communicate your thoughts and ideas and what you're working on. So I'd say those skills are really important. And then from work to bring it to the team, I'd say the big things are basically bringing those same skills back to the team, as well as, like I said, the project management is really helpful to help the team kind of make it through those different milestones and just kind of understanding what that looks like. And then from a technical perspective also, so I work at a CAD company, so I work with Onshape a lot and training people at Onshape. So getting to take my team through the transition this year into starting using Onshape was really helpful to see what it's like for someone to learn it from the ground up, because I think sometimes you can remember what it's like to train someone who already has a little bit of experience or helping them go through that transition. But starting from not having that knowledge and where do I start in teaching you this and what that would look like for you is really helpful for me to kind of formulate those ideas with them and help them get to that technical space of being able to CAD on their own.
That's awesome. I think that's incredible that you're able to kind of bring both worlds together and both sides benefit from the other. It's just like mutually beneficial experience. I think that's super cool. I love to hear that.
Yeah, and I'd say this year the innovation challenge was a perfect example of that, where you're trying to design a product and then you also need to tell the judges about what that looked like and what your team did to get to your solution. So that and the game design challenge I really helped my team with a lot. And it was the team came up with their idea, they made their models of what the field would look like, but how do they tell the judges what they were thinking in a very limited amount of space? And so kind of helping them work through that and what that would look like was definitely a good area to combine both of those sets of knowledge.
For sure. I bet a lot of our first students that are listening right now didn't realize that these skills that they're doing through fun activities like innovation challenge and game design challenge, even infinite recharge at home too, there's going to be that aspect as well. There's a lot of cool stuff that you're learning that's really going to help you moving forward in ways that you never really realize. I've got another question. This is actually from Caitlin from team 1761, the Steampunk Tigers. This is for Erik. What made you interested in robotics? And do you have tips overall about like the path that you chose to get into things? Do you feel like your college, we talked a little bit about college degree, but like, did you feel like there were classes or anything specific that really prepared you for this?
So I knew I wanted to get into robotics when I was probably a junior in high school, and I was really sort of drawn to that. And my path towards robotics has been winding, to say the least. My high school did have a electrical lab, so I was able to do that. And I learned that I definitely wanted to play with electronics with that. When I went to school, or looking at colleges, I knew I wanted to focus on robotics. And I knew that I was looking for something to do. I went to my guidance counselor. Again, this is many years ago before the internet. And I said, hey, I'm interested in robotics. At the time, FIRST had just started. I would have been able to have joined it and would have enjoyed that very much. But the ability to find this kind of club wasn't really available, and it was a little bit harder to do in that environment. Fast forward, looking at schools, focusing on robotics, ending up at RPI because I felt like that was the fit for me. Didn't unfortunately end up doing as much robotics as I would have thought. And then every few years, as I've moved around in my career, I kept touching base with iRobot. Hi, I'm interested in you. You guys do interesting stuff. I had a few interviews, and then later I got this position, which was a good fit for me, building essentially what we call fixtures or robots to break robots. If I had to do it differently, I would have done what you're doing now, which has been in a FIRST organization, because it gives, like, one of the things that's running through a lot of what we're saying is try it. Try as much as you can. Intern. If you can get a kit, a little robot kit, maybe you can't do what you really want to do on the big robot because either timing or this, that, and the other thing. But there's so many other robotic platforms that you can get a VEX, get any small little thing that you can work with so that you can explore and you can go through the process and learning. Because if you're on this call, if you're asking these questions, you have the drive. You just need to do a little bit of practice.
I'm like super amped up after hearing that piece of advice. I think I would have absolutely hopped on that sooner. I like want to go out and get a robot kit now. I want to do all the things. I want to do it. I don't know about all of our attendees. So now that we're talking a little bit about FIRST and that drive a lot of our students have, what is something positive that a FIRST student might bring to a company or a role with a future employer that they can really emphasize on their resume and interviews? Like, I know we've talked about, put FIRST on your resume. It's a wonderful community that you can associate yourself with, not just talking about your technical skills, but if there, I guess McKenzie and Dean, like, was there anything that you specifically did, Erik and Akshay, if there was anything that if you were on a first team, like, what would you want to hear?
So I've done a lot of interviewing and hiring, and I have gone after first kids for a while at multiple positions. And the reason is that you've tried it, you understand the language. So what I would put on your resume, and you should be starting to build a resume now, it will help you in the future, is some of the project-based stuff. So we built a robot. Okay, so as an interviewer who's familiar with FIRST, that means a different thing. So when you go through the interview process, again, you're in the communication zone that we talked about before. As an interviewer with FIRST, when I see this person was on a team and they helped to build the robot and they were on the electrical team, that means a different level to me. But what you're going to have to do is a resume or this communication that you're going through is a sales pitch. You're trying to get them to understand what skills you have so that they can pull those skills, understand what those skills are and how they match up with what they believe they need. So the projects will allow you to have the conversation with these people to say, yes, I know how to solder. Yes, I know I know how motors work. I have an understanding of this. I have an understanding of cameras. I have an understanding of different sensors. I know what an encoder is. A lot of these different things in the automation zone, in robotics, in industrial control, they mean things, and they might not be something that even a graduated senior from a college, even a few years ago, that didn't do a lot of projects, they may not even have this kind of skill set. They may not have played with encoders. They may not have done this. So by putting it on the resume, what you do, the project that you do is you give them a hook, and then you give something that describes what you did with that, what you did for the project. I redid the gearbox. I redid the motors. And then that gives the hook for that person to look at your resume and ask that further question.
So right now, I actually am working with 2 interns that were both FIRST alumni that we recently hired on. And I'd say one of the big things that I've seen with myself and with them is on a FIRST team, you have so many different things going on. So you're basically running a small business where you're trying to figure out your finances, and you're trying to build this robot, and you're trying to do the electrical and the programming, and you're trying to do the mechanical aspects. And so I think one of the things that happen at work too is there's a lot of different problems and things that are happening. And I think FIRST students recognize that I may not know everything I need to know to get this robot built, but I'll figure it out and I will take on this task that I know needs to happen to get this done. And I think just that ability to figure something out and say, I'll step up and I'll do the thing because I know we need to do that to drive ourselves forward. And I think that's a really cool skill that FIRST students have, and that ability to just step up and step into whatever sort of needs to get done.
Yeah, I know that, like, for BAE, for example, I work a bit with, how grants are output and everything for FIRST teams. And one of the big things that they always talk about is building the pipeline. And that is, it's literally using, all of these, you students at FIRST and making sure that you get, the education and everything that you're looking for, because, at some point, all these companies are going to be looking to hire, more and more people every year. And the only way that you get talented people is by giving them the resources that they need. So I know, I'd say probably out of the country, one of the biggest, engineering pipeline development is FIRST. And you can tell by the fact that all these big companies are putting a lot of money into, making sure that it continues to output, more educated and, inventive people.
Yeah, and I'll just echo what has been already said about soft skills. McKenzie said having the right mindset that you'll figure it out even if you didn't know. Those are all the things that are valued by potential employers. And what we're really looking for are transferable skills. So not just what you did, but what can you basically, what did you learn from it that you can bring to your job and basically shine. So yeah, both us as well as our customers have recruited lots of students from who have a competition background, such as First, and they really shine over students who don't have a similar background just because of the additional exposure. Things not working out. You thought something works out, but then it doesn't, and then you have the experience to go and figure it out, right? And it's likely that you'll do the same when you have the actual job. So all these are positives and pluses that we look for.
Awesome. I really feel that as well, being a First alumni and now working in the medical device industry myself. I can see it, and I love that we all recognize that in all of you. So all of our attendees that are here with us today, remember that. Remember this advice that all of our wonderful panelists have echoed thus far. I think keep driving, keep being curious, keep being awesome and trying to just become the best you possible. Because I think ultimately that is going to be one of your biggest strengths as you enter, post high school, wherever you decide to go. I think we're running a little low on time, so I'm going to ask one more question, and then I would actually like to ask our panelists about some advice they might have for you. So our last question comes from McKenzie. So what does your organization do to ensure that employees stay current with trends and technical advancements once they're in the workforce?
Yes, I'd say one of the big things is conferences are always really helpful in being able to attend things like that and helping people do that, as well as providing different resources. So I'd say that always be learning is the big thing, just continuing to learn and providing access to things like LinkedIn Learning or different learning pathways so that people in the workforce can still keep going, or providing tuition help if you want to continue on and get a master's degree or something else. So I'd say it's really important for companies to help people continue to learn as they go on in their career.
Anyone else want to jump in? Go ahead.
Yeah, so I think our company, when it comes to annual reviews, you actually have to demonstrate what you did for your own learning and improvement over the past year. So it's almost kind of mandatory that you have to keep learning, and it's encouraged. So like McKenzie said, advanced education, if it helps you progress in your job. There are also book clubs within our company that people start when they want to read on a new topic and discuss in a group. All of that is encouraged. Conferences, yes, of course, we support conferences and have our representatives take part there. And also, I myself am fortunate that I have been able to invite researchers and educators to come and give talks at Mathworks, and that is another way of educating the overall workforce. So lots of things, yeah.
Awesome. So now the last thing that I want to touch on before we wrap things up today. Does anyone have any advice for, we talked about the at-home challenges, both game design, infinite recharge at home, the innovation challenge. Does anyone have any advice for how to communicate our different challenge solutions? Whether, I know, Erik, you're a judge for any first, so I'm kind of targeting this at you, but McKenzie, Dean, Akshay, if you were giving a presentation at work, do you have any tips on maybe even over Zoom tips now that we're in the middle of a pandemic? Anything you got for our students?
Practice it a lot. Do a couple of dry runs. Have a mother or father or grandfather or someone who's tangentially associated with some notional idea what you're trying to do, but have them run through, have them pretend to be a judge, because these are the type of people that will become judges. You have three general grades of judges. You have the people who were part of the organization before, like McKenzie and Dean. They know this stuff cold, they know the teams, they know the history. That's your first set. You have the people like me. I do it. I've done it for years and years. I do judging. I've dabbled in mentoring, but I'm sort of not as I'm not as involved. And then you have other people who are judging for the first time. This is their first time. We train them as best we can, but they don't have as much perspective as some of the first two groups. So you need to be able to communicate with them. So you need to practice, because they're going to ask you questions that you may have not prepared for if you're just going in cold, if you haven't practiced. They're going to ask you questions like your grandparents might, or like your older sister or uncle or somebody outside who's looking at it from a business perspective. They're going to ask you, how do you plan to do this? A lot of, if you were to go through the entrepreneurship award in years gone by and what that goes through, that they're going to ask similar questions to that. What is the impact? What is this going to do? How are you predicting that? How do you have any thoughts about this? Do you have any thoughts about that? Why is this different? All of the things that we've talked.
Another piece of advice, kind of building on that, is you mentioned that there's different types of judges, but whether it be judges that you're talking to or whoever it is, thinking about who your audience is and what you want them to take away before you start writing the stuff that you're writing. So when I walk into this conversation and I walk away from it, what is the one thing I want that person to remember about us? What is that one thing I want that judge to remember about us? What is our team story? I don't want to just kind of throw the numbers at them or throw kind of the minute details, but what is the overarching thing that I want them to walk away with? If it's that this design is really important and really cool, how do I get them to feel that or think that? So I think that's a big part of it, is just what is your message and what is the thing you're trying to get them to come away from it with?
Yeah, for sure. As someone who's worked on chairmans, who's worked on game design now as a mentor, I definitely agree with both of those pieces of advice. I think it's audience, practicing, everything that your teachers tell you to do in school and you really don't want to do. At least this is stuff that you enjoy talking about and you want to talk about. You want to brag about your robot, you want to brag about your team. Have fun with it, is my little piece of advice that I like to throw in there, because they're going to see the passion when you talk about what you're like. Look at our panelists today. They've gotten so excited talking about the different things that they're involved with, the different interests they have, the different jobs that they've had. We all see that in you whenever you get excited talking about your robot, talking about your team's outreach, whatever it may be. Just embrace it and have fun with it. So we are unfortunately at time. Before we conclude, I just want to throw it out there that Kim put a link to our little social session that we have on Zoom after this seminar is over. So definitely click on the Zoom link in chat if there's any questions that you want to ask any of our panelists, if you just want to get to know any first attendees that are on today. But I want to thank you all for watching. Thank you to our panelists, Dean, Erik, McKenzie, and Akshay. Thank you so much for taking your time to talk to all of us and our attendees. We also want to shout out our sponsors, Raytheon Technologies, BAE Systems, National Grid, Boston Scientific, BNY Mellon, Analog Devices, PTC, and the Fay Trust. My name is Manisha. Thank you all for coming, and we'll see you at our next STEM at Work seminar.
Thank you. This was fun.
Thank you very much.
Thank you.
Thank you.
Have a great day, everyone.